Next, we have MaiteTaboada, and I'm really pleased to have you with us. Maite's topic is using computational linguistics to detect fake news. Maite is an SFU linguistics professor, and she's presenting on some novel research which really lands at the intersection of linguistics, computational linguistics, and data science. Her recent research involves the study of constructiveness and toxicity in online news comments and a comparison of fake and fact-based news stories. Please join me in welcoming Maite.
So I want to talk about how we use computational linguistics to address this problem. And this is research with Fatemeh Torabi Asser, a postdoc in my lab. The basic premise here is that we can detect the language of fake news, that the language in which fake news is written is very different from the language of fact-based news. Forget about the source of the news, the spread, the particular website where it's posted. We just want to look at the language in isolation and see if we can find linguistic patterns that make it different from real news. And the methods we're using here are multidimensional analysis of different linguistic features and machine learning and deep learning methods. In other words, we're using the algorithms that gave us fake news to detect it. So Fatemeh and I started working on this a while back, and we ended up writing a paper about how we couldn't write a paper about this. So this is a paper that is to appear in the next few weeks in the journal called Big Data and Society. And what we say there is basically that, yes, fake news is a problem, and it is mostly a big data problem. It's the availability of lots of data online and the ability to spread it that has made it a problem. But we researchers are trying to solve it with small amounts of data, because the data samples that we have are too small to solve the problem. So what we have in that paper is a call to arms to other researchers, but mostly to the platforms that host so much of that, to make it available and to let us researchers use it to do research, to investigate the characteristics. So as I said, our first task is to find in machine learning, find positive and negative instances of the phenomenon. And this is what you do for any classification task. If you want to find out if an email message is spam or not, you have a lot of email messages that are spam and look for characteristics. So those are the positive instances. And the problem is that you cannot go to fakenews.net and download the entire contents of that website, because fake news publishers publish real news. They often republish information from other sites to make themselves more credible. So they mix fake with fact-based on the same website. So while that sounds like an easy way to get a lot of data, it's not reliable. What we need is individual instances labeled article by article by a human with information and knowledge of the subject matter to tell us that's true and that's not. And that's time-consuming and that's difficult to get. That's where we are in a small data problem situation. So what we have done is go to fact checkers. That's exactly what fact checkers do. Websites like Snopes and PolitiFact and Emergent, they have submissions. So if you suspect something is not true, you can submit it to their website and have experts check it, and then they publish it. So that's what we have done. And we have a data set that we have made available to the public, and it's got about 10,000 articles. In big data research, that's puny. That's, it's a really small amount of data for the kind of work that we want to do. We are doing some work with this data set, and there's lots of numbers there, but two things that to draw attention to. One, that sort of what we call classic machine learning approaches that use features in the text, do the best And the new deep learning approaches, the new algorithms, the new wave of AI does not do as well because the data size, the data sample is too small. So that's my conclusion. We need more data. Send me your fake news articles and we'll use them for good purposes. You can also play with the current algorithm. It's quite flawed. The numbers, the best results we get there are about 73%, so it's not always accurate. But you can go to that website, fakenews.ngrok.io, and paste your favorite fake news story and see if we get it right or not. Thank you.